Hi guys. I'm technically not back until Wednesday, but I did want to record videos for your math lessons this week. So Monday and Tuesday, you will have two videos. So one on Monday, one on Tuesday. Wednesday and Thursday, you guys can work on the homework and it'll be due on Friday. And Friday, we might have a 10-question assessment, but I just want to see how you guys are doing on Wednesday and Thursday, and I'll let you know probably Wednesday night, maybe Thursday morning, whether you'll have that 10-question assessment on Friday or not. So I'm going to go ahead and get started. So we're going to be learning about exponential functions and logs. So today we're going to do exponential functions, growth and decay. You may have seen this before. If not, hopefully I'll be able to answer your questions. I'm going to try and have something on Google Classroom where you can just ask questions and then I can make a video trying to answer all of your questions. So let me erase these quick. All right, so today, like I said, exponential functions, the parent function, and excuse me as I write on this, I'm not used to writing straight on. I like writing sideways, but f of x equals b to the x power. All right, so that's the parent function. F of x equals b to the x power. F of x is also the same thing as y, so if you want to write y equals b to the x power, that's also fine. So under the notes and examples, it says if b is greater than 1, the function is an exponential growth function and is increasing. Now, you guys can write this on a separate sheet of paper if you have a piece of paper. If you want to print this out, I will put it on Google Classroom and you guys can print it out and do it with me if you want there as well. All right, the next one, if b is less than 1, the function is an exponential decay and is decreasing. Okay, and I'll show you more once we get into the graphs of what they look like. All right, so that's just looking at your b value. If it's greater than 1, it's going to be growth. If it's less than 1, it's going to be decay. All right, so an asymptote. A lot of people have trouble with asymptotes, but hopefully I'll be able to clear it up with you. All right, so it's a line which the graph gets close to but never crosses. So again, if you can't read my handwriting, a line which the graph gets close to but never crosses. Okay, so that's an asymptote. Now it says directions classify as an exponential growth or decay. Graph, then identify its key characteristics. So if you look at this, it's, remember, the parent function is f of x equals b to the x power. So our b is actually 2. All right. So since 2 is greater than 1, it's going to be exponential growth. So we can write growth over here. All right. And you can tell just by looking at it. So if we look at number 2, since 3 is greater than 1, we know that's going to be growth. Okay. All right, so back to number 1. First thing you want to do is make a chart. Now, if you don't have a calculator, you can do this by hand. If also you don't have a calculator, you can also use something called Desmos. So I'll show you how to use that. Just give me a minute. So I always like to use 5 points. So -2 to +2. All right, and then you substitute those values in. Again, if you don't have a calculator, you can always go to Desmos and you can figure out what those points are. So -2, if I do 2 to the -2nd, if you have a negative exponent, it really flips your fraction, which hopefully you can see this. I'm going to put it over here. So I guess I can't. I'm going to do it up here. So if you have 2 to the -2nd power, what that really means is 1 over 2 to the 2nd power. So anytime you have a negative exponent, that goes into the denominator. And we know 2 squared is 4. So that really would be 1/4. So if you want to write 1/4, you can. If you know that 1/4 is 0.25, that's also fine. All right. -1, same thing. If it was 2 to the -1st power, you'd really flip it. So it'd just be 1/2. And we know 1/2 is 0.5, okay? 0, anything to the 0 power is always 1, okay? That holds true for everything. And then 2 to the first power is always whatever your base is, so that's 2, and 2 squared is 4, okay? So all you're doing is substituting these individual x values into the equation and then figuring out what your y values are. Now we want to plot those points. All right, so we have negative 2.25, and obviously you're not going to get exactly there. All right, and same thing for me. It's going to be hard for me using the pen that I'm using, but I'm going to try my best. So negative 2.25, I'm just going to get as close as I can there. Negative 1, 1/2, 0, 1, 1, 2, and 2, 4. 1, 2, 3, 4. Now you're going to connect these. Now, this is where our asymptote comes into play. So this is what it's going to look like. Now, this is going to keep approaching 0, but it's never going to cross 0. So how you draw in an asymptote, and you're not really required to do this, but hopefully it'll help you so you can see. So this right here is y equals 0, this line right here. This should never cross it. You will get it wrong on a quiz or a test if your line does cross it, okay? Because that's an asymptote. Think of a wall. You can't go through a wall, can you? So that's the same concept. All right, so make sure you have arrows at the end of both sides, okay? It is a line, it'll keep going both ways. So now for domain and range, end behavior, y-intercept, and asymptote. So the domain are all of your x values. So if you don't know that, you can put it up there, range, y values. And forgive me if you've already learned all this stuff. I'm just coming back, so it won't hurt to relearn some of these things. All right, so domain are all your x values. So you have, okay, here's positive x values, you have some there. Here's negative x values, you have some there. So that means all reals, okay? You can write all reals, okay? There's a bunch of different ways to do it. You can put ARN, all real numbers, whichever way that you have learned before. Range are your y values, all right? So all of your y values, if you look, okay, they're all above 0, right? Because we talked about this asymptote, and your values, this line here, can't go through 0. So it's going to be y is greater than 0. Now, since this line can't touch 0, that's why it's just greater than, not greater than or equal to. Okay, so just greater than. End behavior confuses a lot of people. I'm going to try my best to explain it as best I can. If I have to explain it a different way, just let me know and I'll try and explain it a different way. So this is as x approaches infinity. Okay, so that means as x, these are our x values, keeps going this way, right? They're positive, it's positive infinity. This is really your y value. So if you don't know f of x, that's y. So what it's asking is, as your x values keep getting larger, positive larger, all right, what happens to your y values? Well, let's look. Our y values are going up, right? So they're going towards a positive infinity. Okay, it's like a sideways 8. Now, as x approaches negative infinity, so you're looking at your x values, you're looking to where they're going to negative infinity. We're looking at what's happening to our y. Well, let's look. What is happening to this part of the graph? It's getting closer and closer to 0. So your y value is approaching 0. So let me go over that one more time. If you want to, you can fast forward if you understand it. All right, so again, as x is approaching infinity, so I'm going to write this, okay? So this is as x is approaching infinity, okay? You want to know what's happening to your y values, okay? So up and down values. Those are going up, right? And it's going to continue to go up. It's going to keep going up and up and up, and it's not going to stop. So that's why it's approaching positive infinity. If you want to put a positive there, that's fine too. You don't need to. Now, as x approaches negative infinity, so that's this way. This is negative. Okay, so as your x values go this way, what's happening to your y values? Okay, again, these are your y values here. So they just keep going down and down and down, and they're approaching 0. They never hit 0. So they're approaching, that's what this arrow means. Your y values are approaching 0. Okay, so hopefully that helps. I know that confuses a lot of people. All right, y-intercept. Okay, so where does this graph cross the y-axis? That's at 0, 1, and you can actually see that over here. So 0, 1. All right, asymptote. So that's this line that I drew in the beginning. Okay, what is this line? That is y equals 0. Okay. All right, so moving right along. All right, we're going to do another example. Actually, before I do the other example, let me show you how to use Desmos, just in case you want to do that. So I have Desmos up here. All right, I already typed in f of x equals you. Once you go here, all you're going to do, and I'll redo it for you, you're going to type in Desmos graphing calculator, and it's right here. Okay, I'm going to leave it just to show you. All right, so Desmos calculator. Click on it, it'll bring you to the screen that I was just at. So you're going to type in f of x equals 2. You're going to do shift the number 6 because that's that caret, and then type your x. Okay, it's automatically going to graph it for you. And in order to figure out what those points are, you're going to go to this edit list and here click convert to table. Okay, that'll give you those values that I was talking about, the -2 to +2. It'll give you what your y values are as well. So if you don't want to do this in your head, totally fine. Just go to this Desmos graphing calculator. And I know that you guys probably have the app too. So you guys can, not the Desmos app, but you have a graphing calculator app. So you can go to that as well, whatever way works. So here's this for you. Okay, and those are the exact points that we got to. All right, so moving right along. So if you look at number 2. All right, we already talked about 3 being greater than 1, so this is growth. Again, x, y, we want to do -2, -1, 0, 1, 2. Okay, we always know if you substitute a 0 in for x as your exponent, 3 to the 0 power, that's going to give you 1. So that should be an easy one for you. All right, let's start with -2. So again, 3 to the -2nd power, and I'll try and do it over here and squeeze it in the side. That would really be 1 over 3 squared. And we know 3 squared is 9, so that would be 1/9. Okay, and 1/9, if you type it into your calculator, is 0.1 repeating. All right, -1. If you do 3 to the -1st, that would be 1/3. You just flip it. Okay, and we know that's 0.3 repeating. 3 to the 1st power is 3, and 3 squared is 9. Again, go ahead and graph these. It does not have to be exact. Okay, -1, 1/3, oops, 0, 1, 1, 3, and 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, again, draw your curve. Now, again, make sure, sorry, I'm not going through all the points. Make sure that this does not cross that axis there. Okay, there's an asymptote here, it never crosses it. So domain, again, just like the last one, you have positive x values, negative x values, so your domain is all real numbers. Sorry, that's so messy. Really doesn't matter, but I'll fix it. All right, range, okay, that's your y values, so that's these values. Okay, you don't have any negative y values, and this is approaching 0, right? So your range is y is greater than 0. They're all greater than 0. They don't touch 0, so it's not or equal to. And behavior as x approaches infinity. So as x is positive, what's happening to your y values? They are also positive, so they're approaching positive infinity. As x approaches negative infinity, so we're looking over here. These values are approaching 0. Y-intercept, again, you can look in your graph, it's 0, 1. And your asymptote, again, because it doesn't cross this line, is y equals 0. All right, hopefully that's good. Now, number 3, since this b value is less than 1, this is going to be a decay. Okay, so that's how you can tell the difference. All right, so again, we're going to do the same thing that we did before. Okay, and again, if you guys wanted to type this into this 3 to the x power into Desmos, feel free. I'll do the next one just so you guys get a little more practice with it. Again, I'm doing -2, -1, 0, 1, 2. All right, now again, 1/2 to the -2nd power. You're really flipping this fraction, all right? And before I even do that, your rules for exponents. You're distributing this -2 to both of these. So you really have 1 to the -2nd power over 2 to the -2nd power. And then you flip, because since this is negative, this moves to the bottom. Since this has a negative exponent, it moves to the top. So now you have 2 squared over 1 squared, which we all know is 4. Sorry, my handwriting's super messy on this. Same thing with a -1. You'll have, oops, 1/2 to the -1st, which is 1 to the -1st over 2 to the -1st. Flip it and you'll get 2. Anything to the 0 power is 1. Anything to the first power is itself. So that's 1/2 or 0.5. All right. And then 1/2 squared would be 1/4, which is 0.25. Okay. And you don't need both of these. Okay. I'm just doing it to help you guys. So let's graph it. So -2, 1, 2, 3, 4, -1, 2, 0, 1, 1, 1/2, and 2 1/4. All right, again, we're going to connect our points, and it does not cross this asymptote. So again, I'm just going to write in our asymptote. We know it's y equals 0. We know our y-intercept again is 0, 1. So those stay the same. Now let's talk about domain, range, and end behavior. Domain, again, your x values are positive and negative. So it's all real numbers. Range, okay, again, even though it's going the opposite direction, it's still getting towards 0, right? There's no values that are negative, okay, and it doesn't touch 0. So this is, again, y is greater than 0. Okay, all of your values are greater than 0. As x approaches infinity, so that's these positive values. What's happening to this part of the graph? What's happening to your y values? Well, they're approaching 0. As x is approaching negative infinity, so this part of the graph, all right, what is happening to your y values? Well, they are increasing, right? Sorry, I'm trying to draw over this. It's not letting me. They're increasing. So we have positive infinity. All right, now why isn't it letting me draw anymore? Sorry, guys. There we go. Okay. So, and I did that again. All right, so let's see here. Let's type this into Desmos. All right, so I'm gonna go over here. Now, instead we have 1/2. Oh, I guess they do this. All right, delete. All right, and all right, how do I should just, there we go. To the x power. And again, it gives you your values. Okay, so you can see that it is going in the opposite direction. Okay, and these values are getting closer and closer to 0 as you go. If you ever wanted to type in another number, all you have to do is hit enter, and you can see it just keeps getting closer and closer to 0, but it'll never hit 0. And you can sit here all day if you want to do that, but it won't hit 0. All right, so next one, all right, is 2/3. So 2/3 is less than 0, so we know this is also a decay. All right, now x and y are values, -2, -1, 0, 1, 2. Again, we know that's going to be 1. Okay, so 2/3 to the -2nd power. And I'm just trying to squeeze all this in, I'm sorry. Again, if you distribute, the -2 would be 2 to the -2nd over 3 to the -2nd. And you're going to flip this, would be 3 squared over 2 squared, which is 9/4. Okay, so we have 9/4. Okay, which is 2.5. Okay. All right, -1. So if you put a -1 in here, all it does is flip these, so that's 3/2, which is 1.5. And I did this wrong. This is 2.25. Sorry, guys. All right, 0, 1, we already have 1 would be 2/3, which is 0.6 repeating. All right, and then we have 2, so that would be 2 squared would be 4, and then 3 squared would be 9, and 4/9 is 0.4 repeating. Okay, so graphing this, we have -2, 1, 2.25. We have -1, 1.5, 0, 1. Why did that not stay? 0, 1, we did 1, 2/3, and 2.4. Again, make sure you're doing your arrows all along. You do need to do points. Don't just draw this in. You won't get any credit for that. All right, again, our asymptote is still here. So that's y equals 0. Our intercept is still at 0, 1. Okay. Domain is still all positive and and negative x values. So that's still all real numbers. Now your range. Okay, your range still is everything above 0. So that's y is greater than 0. Okay, as x approaches infinity, so that's these positive values. Okay, what's happening to your graph as it's getting the positive values? Well, it's approaching 0, right? What's happening to your graph as it's approaching negative values? So as we go negative, our graph is going up and it's approaching positive infinity. Hopefully you're not confused on this anymore. If you are, I'll try and find something else for you guys. Now this one I'm not gonna do, but I am going to talk about this 5/2 because a lot of people, if you're just given this and asked to write decay or growth, a lot of people write decay. Why? Because it's a fraction. However, is 5/2 less than 1? It's not. All right. So since it's greater than 1, this is actually growth. All right. So this will actually go up. Okay. It won't go down like the one numbers 3 and 4. All right. So tomorrow, I'm going to give you guys another set of notes. Wednesday, Thursday, you'll work on the homework. And if you have questions, you'll have some time to ask me. You can either email me or write questions on Remind, or you can type questions into Google Classroom. And I'll try my best to answer all those questions. All right. So do your best. I know you're probably stressed because now everything's switched to online and you're not used to learning that way, but I'm going to try and teach the way that I would teach in the classroom. All right. So good luck. If you have any questions, please ask. Don't just sit there and just think, oh, I don't want to ask this, but I don't know how to do it. Okay. Ask questions. I'm not going to get mad at you. I know this is different for all of us. All right. Have a great night, and I'll post another video tomorrow. All right. Bye.